Today's video lesson is on solving systems of equations using graphing. Make sure that you have set your note-taking up correctly. If you do not set your notes up this way, you will not receive credit for your notebook check. At the very top, you need to have a line across the top for your topic. Today's topic is solving systems using graphing. You need to have a line about 1.5 inches from the left-hand side to allow space for you to ask questions in class. You need to have a line about 4 or 5 lines up from the bottom of the paper for a summary, and then section 3 is where you will actually be taking your notes. Let's start with some review on slope-intercept form. So currently this equation is not in slope-intercept form. Slope-intercept form looks like this. It is y equals mx plus b. Slope-intercept form is useful because if I can identify the y-intercept, which is my b value, and I can identify the slope, which is my m value, I can then graph any equation that I like. But I need to isolate y in order to do that equation. I'm going to draw my line down to show my two sides, and I'm going to move the x values to the other side. So I'm going to do that by adding 2x to each side. That leaves me with 3y. And then I want to put the x first, it's a positive, and the 12 second, it's a negative. So 3y equals 2x minus 12. Y is still not isolated. I need to get rid of the 3, so I'm going to divide both sides by 3. The 3's cancel. Hopefully they should cancel if I could draw a straighter line. And you get y equals 2/3 x minus 4. This allows me to identify the y-intercept, which is -4, which would be my starting point when I'm ready to graph, and my slope, which is 2/3, which will be my rise and my run to get to additional points to graph those lines. Once we have that in slope-intercept form, which is what we just did on the last screen, we got this equation into slope-intercept form. I now know that my y-intercept is -4 and that my slope is 2/3. My y-intercept is my starting point, so I put a dot there. And then I need to go up 2. The positive 2 is telling me to go up 2, and the positive 3 is telling me to go to the right 3. So I'm going to go up 2, 1, 2, and to the right 3, 1, 2, 3, and put an additional dot. And I can do that repeatedly, up 2 and to the right 3, up 2 and to the right 3. And notice those create a nice straight line. If I want to go in the opposite direction, I just make both of these opposite. I go down and to the left. So I can go down 2 and to the left 3, down 2 and to the left 3, down 2 and to the left 3, and again that makes a nice straight line for me to connect. Let's try another one. This is already in slope-intercept form. The y-intercept is the number that's by itself, so the y-intercept is 1. The slope is -4/5. This time we have a negative on our slope. There are not two negatives there. This can either be treated as -4/5, in which case we would go down 4, but that's a +5, and we would go to the right. That's one way to do it. So if I do it that way, my y-intercept is 1, and I need to go down 4 and to the right 5, and put a dot. Down 4, to the right 5. If I wanted to switch it around, I could rewrite that as 4/-5, in which case I would go up 4, but to the left 5. So I would go up 4, 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5. Up 4, 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5. And that's created a nice straight line for me to graph. What I cannot do is treat that as if it is -4/5, because that would be both down and to the left. And a negative divided by a negative actually becomes a positive. So watch what happens if I do it that way. I would go down 4, 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5. And now that's actually creating a positive slope, which is not what I wanted there. But our real lesson today is on systems of equations. So you're going to want to pause the video and write your definition here. A system of linear equation consists of 2 or more equations made up of the same variables. So 2 equations made up of the same variables. We focus on linear equations, equations that graph lines. The solution to a system of equations is the intersection point. The solution should be written as a coordinate point x comma y. Make sure you pause the video before moving on. The solution to a system of equations is where the two lines intersect. So if we have two equations, this is a system of equations. Sorry, my box is kind of funky there. Y equals negative 3x plus 2 and y equals 2x minus 3. For the top equation, the y-intercept was 2, and they went down 3 and to the right 1 and made another point. For the other equation, the y-intercept is negative 3. They went up 2 and to the right 1 and made another point. Now, to find the solution actually isn't the graph. The solution is the point of intersection. In this case, it is to the right 1 and down 1 right there at that yellow circle. So the solution to the system is 1 comma negative 1. But sometimes weird things can happen. Sometimes you have one solution, in which case you write your answer. In this case, it would be negative 1 comma 1. But sometimes you will put the equations into slope-intercept form and graph your two lines, and the two lines lay exactly on top of each other. They intersect everywhere, in which case you would say your solution is infinite solutions. Sometimes you'll graph your lines and they'll have the same slope, which means they'll be parallel, which means they will never intersect. And so in that case, we would say no solution, or you can write that as a circle with a line through it to identify that as no solution. And maybe we should write this as infinite solutions. You can just make a quick sketch of these on your notes. You don't have to make them in detail. Just show two lines that intersect, two lines that overlap, and two lines that run parallel to each other, and label those as having one solution, infinite solutions, and no solution. Make sure you pause the video and finish those notes before we move on. Now, suppose I need to graph my own lines. We want to solve the following system of equations graphically on the set of axes below. So my first equation is y equals negative x plus 2. Well, I want to remember that there's always an invisible 1 in front of any variable that doesn't have a coefficient. So for this one, my y-intercept is 2, and my slope is negative 1. I can turn that into a fraction by putting it over 1, and so this is telling me to go down and to the right. So my y-intercept is 2, and I'm going to go down 1 and to the right 1, down 1 and to the right 1, down 1 and to the right 1. And I'm going to continue doing that over and over until I fill my graph. That's going to assist me with being able to find the intersection point. Now, if I want to go the other way, then I go up and to the left. I do the opposite of both things. Up 1 to the left 1, up 1 to the left 1, and so on. And I do that until I fill my whole graph. This will be a little easier for you to do on Delta Math. You'll just make the line and you won't have to put all of these points. But if you were doing this on paper, you wouldn't want to show all those points like that. All right, there's my nice straight line for the first one. For the second one, my equation is y equals 2x minus 4. So my y-intercept is negative 4, and my slope is 2. Again, I can rewrite that as a fraction by making it 2 over 1. That tells me that I'm going to go up 2 and to the right 1. So my y-intercept is negative 4, so I put a dot on the y-axis where the y value is negative 4. And I'm going to just stop when I get to an additional point, and there it is. Now, I've done all of this work, and my answer is going to be wrong if I don't write the actual solution. The solution to this is the intersection point. Well, that's the point over 2, up and down 0. So it's 2 comma 0, and that's your solution. Now, sometimes your equations won't be in slope-intercept form. This first one is, the y-intercept is negative 4, the slope is negative 3 over 2, the negative 3 is telling me to go down and to the right. There's not two negatives there, it's not down and to the left. So I put my y-intercept at negative 4, and I'm going to go down 3 and to the right 2, down 3 and to the right 2. If I want to go the other way, I just make both of these opposites. I go up and to the left. So I go up 3, and to the left 2, and so on until I fill the whole graph. And I connect those with a nice straight line. Now the problem is this equation is not in slope-intercept form. Y is not isolated, so I have a little bit of work to do on it. I need to get y alone. We said at the beginning to put something in slope-intercept form, you want to move your x's first. I'm going to remind myself that any variable that doesn't have a coefficient actually has an invisible coefficient of 1. I move the x's to the other side using subtraction, so I subtract 1x. And then I'm going to put an error here. I bring down my y. This is negative 1x minus 6. I have an error here. What do you think that error is? Well, it's right here. That y should have been a negative 1 in front of it. In order to get rid of that negative 1, I can divide by 1. All that does is change the sign of everything. Negative 1 divided by negative 1 is positive 1. Negative 6 divided by negative 1 is positive 6. So my y-intercept is 6. My slope is 1. If I want to turn that into a fraction, it's 1 over 1. So I go up 6, and I go up 1 and over 1. And notice, this is actually taking me away from the line. So I need to go the other direction. I'm instead going to go down and to the left, 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 until I find my intersection, which is right there. Now I've done all of this work, and my answer is still not going to be wrong because I haven't actually written my solution. My solution here is the intersection point, which is negative 4, comma, 2. All right, in your summary area at the bottom of your page, I want you to write this down. To solve a system of equations using graphing, graph the lines, then identify the intersection point. And once you have that all written down, you are done with this video. Have a great day.